Hi guys, today I have another work that we can do via Excel. So that is if you have a data sheet with the data that we need for the calibration curve, and I'm gonna teach you from this video how you gonna get an unknown thing, like how you find a concentration of an unknown sample or something you need to get through a calibration curve. So today I'm gonna teach you that. So I have already gone through all the stuff, but I'm gonna do again all this stuff with you. Then I think it's easy to understand, and you can follow me from step by step, right? Okay, so what we gonna do is, so let's hope copy. So I'm gonna have another one. Okay, because I need a raw data file. Okay, so here, so this one, so I have used for these ones, I have used CIC, combustion ion chromatography. So these are the samples I gave to the instrument to give me signals. Then we can get the calibration curve. So in there, so I'm actually measuring the fluoride content, and here I have given 10 nanograms of fluoride, 25 nanograms of fluoride, kind of thing. So that's the thing. And then for this one, for 250 nanograms of fluoride, it gave me this area, the peak area, and the height of the peak, kind of thing. So it will differ from whatever you want to do, so it's totally fine. It could be a chromatogram, it could be something some absorbance value for a particular concentration. It doesn't matter. So the calibration curve is calibration curves. We are giving the instrument the known concentrations and asking for the corresponding signal, and after we get it, then we can inject our samples to get the concentration of those, because we don't know, in this scenario, we don't know the concentration or content of fluoride or anything. So that's the thing we're gonna find, right? So these are my unknowns, these samples. So I have inserted into the instrument and it gave me this data. So I'm gonna find the corresponding values for this data set. Okay, now we have the data set over here. Okay, so now I'm gonna have to plot the calibration curve. So what you need to do first is, as we are having 3 signals for the same concentration, that means we have triplicates. I did it in 3 times, so that's because in analytical field it's better to have 3 signals for each concentration. So now to go with the the calibration curve, I'm gonna use the average. So I'm gonna have sample over here and the copy. This is actually average area. Oh, I have typed it again. Okay, average area. So here I have 10, 25, 50, 100, 250, 500 and 1000, right? So then I'm going to take the average. As you know, equal mark, type average, you can select from there, and then select the 3 signals. Oh, not height, we need area. So I'm actually gonna go with the area. You need highlight the area you want and press enter. See, it's giving you the average signal for that particular concentration. Likewise, you have to do it again and again for entire setup. Okay, so likewise you can select and select the 3. In the other words, you can actually select this and drag down, but what it's gonna do is, it's only like shifting only a one square, so you can select it and take it down. Then again you can do this one and take down. Again you can do this and take down. So it's okay, whatever you feel like easy, go with it. But remember, you should select the correct values, otherwise your calibration curve will look weird. Okay, now I don't actually want these number of decimals, I'm gonna go with this. Now it's nice. So I have the sample and the average area, and also I'm gonna need the standard deviation. That's because, you know, in the, like, when you are plotting a graph, it's better to, like, if you are representing actually this data to someone, it's better to have not better actually, the like the error bars are like place like a huge row, because it gives you whether you 3 samples, like this replicates it in the range, and is it going through like trend line, blah blah blah. So it's a like a good thing to show. So I'm gonna go with standard deviation 2 equals, so standard deviation, so don't select population because we don't have a population, this is like a small sample set. Select this one and select the 3 values you want. Likewise, go down. Okay, this is here, this is here, this is 100, and this is 500. I missed this, so I'm gonna do it again. And this one 1000. See, now I have the standard deviation of those, so I don't actually need this bunch of decimal numbers, so I'm gonna get rid of that, and then gonna make a nice table. See, now we have the data set that we need to prepare the calibration curve. So I will do like this. I'm gonna get this one and right click and select data, because I'm gonna add like step by step everything, because I feel like it's easy to like give you this stuff that way and you can understand easily. Series name, okay, fluoride contained, maybe fluoride standard, fluoride calibration curve, ration curve, okay. X series, X values, it's asking for X values. What are those? These are obviously, those are the X values. And Y values, these ones, nice, hit OK. Okay, now you have the points. Now you need to get the trend line, because in your calibration curve you have to go with trend line. I'm gonna go with like select the graph, plus sign, trend line. Don't tick this one, go with the arrow and go to more option. Then it's asking you, do you want to like make the intercept 0, blah blah. So we don't need those ones because we are not making our data. So we need the display equation on chart. No need to set up the intercept, but we need our squared value, yes of course. And then you can have the trend line over here, and you have the equation for that trend line, linear regression. Then so we need to have axis titles, yes. Now you have axis titles, type A. Here is the, oh, not the average area, this is the sample concentration. In my case those are in nanograms, and axis title over here will be average area, nice. Now you have the calibration curve. Okay, so one can use these data. Oh, wait, I forgot something. Where? So I forgot to put error bars. Now don't hit this one. You need to go for the more option and select the graph icon and then go to custom, then hit specific values. Actually you have values, so we're gonna put those. So for the positive errors, select this and put like that, and for the negative errors as well, put like this, then hit OK. Oh, nice. See, now you have your errors. Oh, did I select something? Oh, no, okay. So see, obviously then you can see whether you have like much deviation within your like points, triplicates. See the I think this is 250. 250 has a lot more error when compared to the three values, 250. Yes, and then here the 1000 has more error. See, 1000 has more error when compared to the okay. So see, so with those results, oh, I selected the wrong one. See, so I told you need to select the correct ones. Obviously these shouldn't be 0. I will make it. See, otherwise we're gonna do a wrong thing here. Okay, I need more decimal to see the values. Now you can see. Oh, nice. Okay, so see, you need to be careful. I also did a wrong thing, so selected actually the wrong column. I don't need it. I'm going with area, so you need to stick with area. Now you have the data and whatever the things like the equation thing over here. Someone can use this values like this equation to go with the calculation, but you know there's a function, right? Linest. Do you know? So if when using linest, you have to put the x values here, y values here, and then you have to go with the linest, whatever the values given by the linest. So okay, so equal mark linest, select that. So see, it's asking for known y's. Yeah, we know these y values, and then comma, and then known x, these values. Yes, we know those. And then constant is like asking false or true. So type true, again true, right? And then hit enter. Okay, so the first value here, I will highlight it. That's the slope of the graph. Okay, so if you like think it's not the one, you can compare that value with this value. See, it's obviously the slope of the graph. And then the opposite value over here, I will color it in another color. That's the intercept. Okay, so now you have the slope, intercept, and that means you know the y equals mx plus c, y equals mx plus c. Okay, so some can like write the same equation as a equals bx plus c. So some may use the equation format as y equals mx plus c, and some may use a equals bx plus c. So it doesn't matter. So here we have y equals 0.00463, right? X plus 0.015342. So that's the equation we have now. Now we when comes to the now we are actually done with the calibration curve, the whatever the data. we gonna obtain from the calibration curve is here. Okay, here. Now when we are moving to our unknown samples, what is the value we have? Y or X? Y, right? Because these are the areas, Y values. I need to find the X. I need to find the X value. So how are you gonna find the X value? Okay, for the easiness, I'm gonna take all the data out from this. So I'm gonna take copy, paste. Okay, these are the data values we have. This is my sample. This is the area. So I need to get the concentration. In my scenario, I'm telling it again, it's in nanogram. Okay. Okay, I'm gonna make a real good table over here. You can. Okay, nice. Now, how we are gonna get the X, like X value? How you gonna like make the equation, this equation to get X value? So that when you are doing the math, it's easy. X equals, so you are taking this X out. To get X out, what you have to do is you have to subtract. So Y gonna be there, subtract 0.015342, and now this part in this equation, this part is over in the other side, right? Plus goes to here, minus, and now you have this value to divide. Okay, so this one divide by 0.00463. So this is the way you this is the way how you gonna take X values. Now for this value, I'm gonna get the value. How you gonna get it? So my Y value is this, right? Minus intercept. I'm gonna select this one. Okay. Then divide by which value? The slope here, right? Then enter. Nice. This is the one. Now this is the Y, like the X value that corresponds to my sample number 3. Now as you see, the intercept and slope is like the same for the rest of the calculation. Then what you can do is you can put dollar mark. Then you don't need to select them again and again, because the part of that equation stays as it is. So you don't need to select them again. What you have to do is just drag down like this. Then you're gonna get the corresponding equation by selecting everything. See? Like that. So in this scenario, I don't need the decimals, so remove those. See, these are the values for my unknowns. So I have this much of fluoride in the sample and this much of fluoride in the sample. So likewise, this is our final answer for our unknown sample. So this is the way you have to do to get whatever the things that you need from unknown using a standard calibration curve. So I hope this is so easy. So I think everybody understood what I'm telling here and what I'm trying to do here, and with the same kind of video, let's meet again. Bye.